Transformations also occur in exponential functions. The relationship between the general transformations formula and exponential functions with transformations are shown below. When performing transformations on exponential functions, the domain, range, y-intercept, and asymptote will change. Let f of x equal 2 to the x power. Graph g of x equals 1/2 f of x. Then describe the transformations that map the graph of f of x to g of x. Alright, so let's take a point here, 0, 1. When we plug in 0 here, we get 2 to the 0 power, which equals 1. So if we take that and plug it in here, so this would equal 1/2 times 2 to the x, so this is what g of x is. So if we plug 0 in here, we get 2 to the 0 power, which is 1, times half. So the point will be at 0, 1/2 instead of 0, 1. If we look at this point, 2. So if we plug in 2 for x, we would get 2 squared, which is 4, times 1/2, which is 2. So that would be here. So this point is at 2, 2 instead of 2, 4. So our graph looks something like this. You can see that the graph of g of x has vertically shrunk towards the x-axis with a factor of 1/2. Let's analyze the function. So we have g of x equals 1/2 f of x, where f of x was 2 to the x power. So this equals 1/2 times 2 to the x. What's the domain? Well, the domain is all real numbers, which is from negative infinity to positive infinity. The range is from 0, but not including 0, up to positive infinity. So 0 to positive infinity, and we have make sure not to have a bracket here because we're not including 0. The y-intercept is right here at 0, 0.5. The horizontal asymptote is the x-axis, and that's when y equals 0, because this line will never cross the x-axis. And this is an increasing function. And there we go. Let f of x equal 2 to the x power. Graph g of x equals negative f of x plus 1. Alright, if we write out g of x using the actual function 2 to the x, that gives us negative 2 to the x power plus 1. Let's look at this point here. When we plug in 0 to f of x, we get 1. What happens when we plug in 0 here? 2 to the 0 power is 1. Negative sign gives us negative 1, plus 1 gives us 0. So the point is now at 0, 0. If we look at x equals 2, that would be 2 squared, which is 4, negative, so negative 4 plus 1 gives us negative 3. So the graph of this function is going to look something like this. You can see that g of x is a reflection about the x-axis, but also a vertical shift up 1 unit. Let's analyze the function. G of x equals negative f of x plus 1, where f of x is 2 to the x power. The domain is all real numbers, so from negative infinity to positive infinity. The range is from negative infinity up to 1. You can see that there is a horizontal asymptote when y equals 1. So the range will be from negative infinity to 1, but not including 1. So we're going to have a parentheses, not a bracket. The y-intercept is right here at the origin, 0, 0. And you see that from left to right, this is a decreasing function. And there we go. Let f of x equal 2 to the x power. Graph g of x equals 2 times f of negative x minus 3. Then describe the transformations that map the graph of f of x to g of x. Alright, so let's rewrite g of x using the actual function 2 to the x power. So that's 2 times 2 to the negative x, because we have f of negative x here, minus 3. Alright, so let's look at the y-intercept. When x equals 0, if we plug 0 for x here, we get 2 to the 0 power, which is 1, times 2, which is 2, minus 3 gives us negative 1. And now let's see when x equals 2, what does this equal? So 2 to the negative 2 power. So let's rewrite this as 2 times 1 over 2 to the x power minus 3. So this is just a nicer way to not have a negative exponent. So when x equals 2, this becomes 1/4 times 2 is 1/2 minus 3. So we have 1/2 minus 3 is going to give us negative 2.5. So that's when x equals 2. We have a point down here. What about when x equals negative 2? So if x equals negative 2, we would have negative 2 in the exponent here, so it would flip back up to the top. So that would become 2 squared, which is 4, times 2, which is 8, minus 3 is 5. So we're going to have this point right up here. So this looks something like that. And you can see that here, this portion, f of negative x, gives us a reflection across the y-axis. We have the 2 out here giving us a vertical stretch with a factor of 2, and this negative 3 gives us a vertical shift down 3 units. Let's analyze the function. The domain is going to be all real numbers from negative infinity up to positive infinity. The range is going to be from negative 3 up to positive infinity, because you can see that there's a horizontal asymptote right where y equals negative 3, since we have this negative 3 vertical shift. The y-intercept is right here at 0, negative 1, and from left to right, it's going downhill. It is decreasing. And there we have it.